Okay, we're looking at 4A and B. Um, what makes 4AB not so bad is one thing you have to make sure you realize. The equation for volume of a can is pi r squared h. But if you think about it, when you put the water into the can and you're pouring stuff into the water into the can and the water level goes up, the radius isn't changing. So you can actually put the 1 in. Now they don't say 1, they say the diameter is 2, and you have to infer that it's 1. And that, you know. So it turns out that the equation is very simple. Now remember how we take derivatives. V prime is pi h prime. Okay. Remember, you have to do implicit differentiation on both those because the thing that's happening here is time, right? It says find the rate of change of the volume of the water in the barrel with respect to time when the height is 4 feet. Now, the key to this question is h prime, and actually I wrote it up for B. They tell us what that is. They give that to you in the question. It's negative 1/10 times the square root of h, right? So then you just got to put that in, right? Negative pi over 10 times the square root of what time is? Oh, they want us to do is when h is 4, right? Square root of 4 is 2, so you get what? Negative pi over 5. What are the units on this thing? Oh, cubic feet per second. Cubic feet per second. Remember, we're finding V prime here. Okay, so on the first question, when there's water level is 4, what we know is that the water is leaking out of the tank at negative pi over 5 feet per second cubed. So there's the rate of change of that volume. Then the second question is the height of the water, when the height of the water is 3, is the height going up or is the height going down? Is the rate of change positive? So it wants to know, that's not whether the rate of change is positive. It wants to know whether h prime is going up or h prime is going down. That's the question, right? Now, what you want to do is you want to think of it this way. When is a function increasing or decreasing? When its derivative is positive or negative, right? And we're doing this at 3 feet, right? So h is 3. So how would I know whether a derivative is positive or negative when its derivative, the second derivative? So then you're going to take the derivative here. Now be careful. It's time, right? So it's negative 1/2 times h prime. So you get h double prime is negative 1 over 20 times 1 over the square root of h times h prime. But h prime is this thing here. So you get, it's a bit convoluted, isn't it? 1 over square root of h times negative 1/10 square root of h. Oh, that's cool. The square root of h's seem to cancel out. That's weird. Now, negative times a negative is a positive. Huh. I did not expect that. Let me check my work. Hold on. That doesn't seem right. That does not seem right. Oh, it is right. Huh. Notice that the second derivative is not dependent on the height. The height cancels out of that question. Not that it matters, but that's positive, isn't it? That's positive. So that must mean that at 4 seconds, the height, 3 seconds, the height is increasing. Yeah, I did not expect that to cancel out. So, but here's the idea: is the second derivative is positive, so that means the first derivative would have to be increasing, and that would just have to be the assumption there. Since the second derivative is positive, the rate of change of the height is increasing. What's weird to me in this is it says at 3. Well, that's true, because the only reason the at 3 is there is because of at 3 is because it asks for at 3. Turns out there's no h in the question, so the second derivative is always positive. Anyways, not a big deal. Okay.